Hello dear students, how are you all? I hope you all are fine. This is the part 2 of your chapter Metals and Non-Metals from your grade 10 NCERT textbook. We have already completed in part 1 about the physical and chemical properties of metals and non-metals. We have seen certain metallic bonds which makes the metals hard. We have also seen certain ionizing compounds which are formed when metals and non-metals react with each other. We have practiced certain molecular formulas of ionic compounds. We will continue to do so and then we will start with the next topics in this part 2. As you can see on the screen, there are the chemical formulas for ionic compounds. We are following crisscross method. Let us see how by this method we are going to write the chemical formula for the ionic compounds. So first thing first, we have taken the example of lithium oxide. You can see lithium oxide. Likewise, when we draw electron dot structures, we usually see what is the valence electron and then we just write them, just make the dots around that element, right? Similarly, as you can see, lithium electronic configuration 2,1 since its atomic number is 3. So what we'll do now, we will write the valence electron under the element. You can see here lithium plus 1, oxygen minus 2, because lithium needs to, what does the lithium wants to do with this one? It is going to withdraw this one, right? So we already know in metals, whenever they withdraw their one electron, they get the charge positive, right? And likewise, when the non-metals used to accept the electrons, they get the charge minus. So we will write these valence electrons with their charges under these elements, you can see here, and then we will do crisscross, right, with the lithium, and it becomes the subscript, okay, like an atom, number of atoms. And here the oxygen has positive 1, so you can show it or you cannot show it, it's up to you, okay. So it will be the formula of an ionic compound. Like this, we can follow the crisscross method to make the molecular formula for an ionic compound. Similarly, if you are going to see the next example, it's carbon dioxide. You can see we have written the valence electrons and then we have put the valency under those elements and then we follow the crisscross method. So oxygen valency becomes the atom of the carbons and carbon's valency will become the oxygen's atoms. Likewise, we have written them like this. So we can cancel it out more, make it to the simplest answer, okay. So this will be the answer, carbon dioxide. We are going to take one more example, sodium oxide. You can see we have written the valency like this and then we have followed the crisscross method and we got the answer, sodium oxide. So like this, we can form the structural formula of various ionic compounds by following the crisscross method. We continue to learn about the points which we are going to cover in this part 2 section is going to be the reactivity series of metals, occurrence of metals and non-metals, and then we are going to extract the metals through various processes. So let's get started. First thing first, we are going to learn about the reactivity series. Series is a list of metals in which we are going to easily understand which metal is highly reactive from the other one, or the reaction of metal with certain other compounds like oxygen, the water, how do they react when they get combined with these certain compounds. Reactivity series shows which are the most reactive metals and which are the least reactive metals. You can see the list here on the screen as well. Potassium, sodium, it's like from the most reactive elements to the least reactive elements. You can see these are the most reactive elements and when we come down, these are the least reactive metals, okay. So reactive metals that show the most visible changes in a chemical reaction, for example aluminium, and when we talk about the gold, it's like a least reactive element. Reactivity series, we can use a reactivity series to predict whether a metal can displace another metal in a single displacement reaction. A more reactive metal will displace a less reactive metal from a compound. As you can see, magnesium plus copper sulfate. Here you can see magnesium and copper sulfate are there. So this magnesium will going to displace the copper, right? Because copper is the metal which is present in the least. Here you can see magnesium is more reactive from copper. That is why magnesium will displace copper from copper sulfate, and it will get connected or joined with the magnesium sulfate it will be, and copper will get released. Because where does the metals comes from? Metals has a ore. Okay, metals comes from the ores. Okay, and ores comes from the rocks. Ores, and in order to get the pure form of metal. Types of ores: there are oxides, sulfides, carbonates, and halides. Okay, so whenever the metal get react with oxygen, it form oxides. Whenever the metals form a compound with the sulfur, it form the sulfides. And whenever the metals form the compound with the carbon, it form carbonates. And when the metal combine with halogens like chlorine, fluorine, bromine, iodine, they form what? Halides, like a sodium salt, potassium chlorides, all this halides. Okay, metals sometimes can be found in the pure form, and sometimes they are formed in the as a compound which get reacted, which get combined with oxygen, carbon, halogens. So whenever metals found in the pure form, all the metals like gold, platinum, silver, they can be found easily in the pure form, right? They are less reactive also. These metals do not easily combine with other elements, which is why they are found relatively pure state in nature. Okay, so gold, platinum, and silver is less reactive. They cannot form or combine with reacting metals from ores involve mining, followed by crushing, concentration, and finally the extraction of metal from the concentrated ore using the methods smelting, electrolysis, and reduction. Smelting is like heating it up, heating the metal compound in order to extract the metals from it. Electrolysis is like when we make that metal compound to go through certain electric current, that is electrolysis. And then reduction is also like when we need certain reducing agents to extract the metals from that compound that are done in order to extract metals from the ore. We have, that is why we have studied about the reactivity series, because in reactivity series there are certain more reactive elements which can easily displace the other metal, right? Which are lighter in reaction, right? So like we have studied that magnesium can easily displace copper from the copper sulfate, right, in order to form the magnesium sulfate, right? So like this, the highly reactive element or metal can displace the low reactive or low reactive metals, and then can form the metals, right? Now we'll talk about electrolysis. Basically, electrolysis is the basic method in which the extraction of metal is done from the compound. What is it? Electrolysis is a process where electricity is being used to break down the compounds into their metal form. For example, if we take the example of H2O, that is water. So whenever electrolysis has been done on it, when the current is being thrown in this compound water, so H is separated out and oxygen is separated out. Whenever the breakdown of metal compounds happen into their metal form, that is known as electrolysis. Reducing agent. A reducing agent like carbon is used to remove oxygen from metal oxides, reducing them to pure metal. We have seen now that carbon is present at the middle of the reactivity series. So carbon is like, it can helps in reducing or reduction of metals from the compound. How it works: in electrolysis, an electric current is passed through a molten or dissolved metal compound, causing metal ions to move to the cathode where they gain electrons and become metal. This What are the examples of metals which goes through electrolysis are aluminium, copper, sodium, and the metals which can easily be extracted from the reducing agent like carbon, so that are zinc, lead. All right. Activity series, here we can see which are the metals which need electrolysis for their extraction, or there are certain metals which can be reduced by through the reducing agents as well. Okay, and there are certain more metals which are so low reactive that can easily be found native in that state, in their pure form, like we have already studied, silver, platinum, and gold. Extracting metals low in the activity series. Metals low in the activity series are very unreactive. Like this, we are talking about silver, gold. The oxides of these metals can be reduced to metals by heating alone. So they are majorly be present in the oxides form, or they are less reactive, so they can be purely available in the earth. However, if certain low reactive element is being found to get attached with sulfur, so we can easily reduce it out by burning it, right? We need to make the oxides of it, and then we can have the purest form of that metal. Now, why does this burning required? Because we need to change that metal into metal oxides, okay, or metal sulfides, metal carbonate. We need to change them into metal oxides because metal oxides are easier. When we talk about the extraction of metals, we talk about the extraction of metals in the middle one, because we have already learned about the extraction of metals at the lower part of activity series. We will see the extraction of metals in the middle one. They are going to reduce by the reducing agents. As I have already told you, every metal sulfides, metal carbonates needed to be reduced to form oxides, because at the oxides it is very easier to extract the metal from the metal oxides. Alright, so these are the example. First of all, when there if there is a zinc, if there are the metals which are being combined with the sulfides, or more like they are sulfides, so they first so they go under the process known as roasting, in which they get reacted with the oxygen. So sulfides, when get reacted with the oxygen, it is known as roasting, in order to change into oxides, metal oxides. Okay. And if we talk about whenever the is present in the carbonate form, it always get reacted, or it will further heat it. Okay, so all the metal carbonates further heaten up in order to form the metal oxides, and this process is known as calcination. Always remember, sulfates, when they are converted into oxides, that is known as roasting, and whenever the carbonate is being heated up, they are known to convert into oxides, they are known as calcination. There is one more concept as discussed by NCERT, that is about corrosion. Corrosion is considered as rusting, right? Usually it happens on the usually corrosion or rusting happens on the iron metal. Okay, so basically when iron metal used to get react with oxygen, then it gives out FeO4, iron oxides, right? So whenever the iron oxide is formed, that this iron oxide is basically termed as rusting, which is usually occurs on the iron metals. Okay, yes, by we can polish the iron metal, or we can get the coating of zinc on it, and that coating of zinc is known as galvanization. It is a method of protecting the steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. So you can polish these metal elements like iron and or steel, or you can make a coating on it of a zinc. Okay, that is known as galvanization. Electrolysis of molten states. So why electrolysis? Why do we need to learn about electrolysis? Because whenever we need to extract the metals, there are three processes majorly. First, you can just find the metal in its pure state, which are less reactive, like silver, platinum, gold. The other one, you make use of reducing agent, which we have already done, like carbon, yeah, oxygen, and then third one is electrolysis, which is majorly used for most reactive metals. Okay, so what does this electrolysis do? Electrolysis helps in extraction of metals. Okay, and then from a compound you can extract the metals, and then you can find it inside the solution with single constituents or single elements inside the solution. We are going to see how we are going to perform electrolysis. What is electrolysis? Electrolysis is the breakdown, also known as decomposition, of a compound using an electric current. So basically we need more power or energy to perform electrolysis. When we pass that compound through an electric current, we can find two metals, or decomposition of those metals from a compound, we can extract the metals from electrolysis. What is an electrolyte? So basically whenever we to perform electrolysis, we need a beaker, the solution, and these two terminals. First, this positive terminal is known as anode and the negative terminal is known as cathode. Okay, and we just dip the metallic compound. Actually, this solution is like molten state or molten salt of that compound. Okay, and this molten salt of that compound is known as electrolyte. So basically this blue color solution is electrolyte, where the molten salt of that compound is being filled inside the beaker. Electrolyte is a substance which conduct electricity when molten or in solution. Electrolytes contain free moving ions which are attracted to the oppositely charged electrodes. The electrodes connect to DC supply like direct current supply. So cathode is the terminal on the battery, that is negatively charged electron. In electrolysis, positively charged ions move towards the cathode. The anode is the positively charged electrode. In electrolysis, negatively charged ions move towards the anode. So basically in electrolysis, what we are doing, we are scattering, we are decomposing the whole compound to get the single element or single metal from that compound. Okay, we are separating the compound. So we have taken an example of calcium chloride. So what we'll do now, positively charged calcium ions move to the negative electrode where they gain electrons to form calcium atoms negatively. So basically what we'll do now in electrolysis, we will take a molten salt of this calcium chloride as an electrolyte, and we just dipped these electrodes, positive and negative electrodes in it. So we already know that in this electrolyte now +2 ions are there and negative ions are there. -1 is for chlorine and positive ions are for calcium. So whenever we pass the current through it, the positive one will go to the negative one and the negative one will goes to the positive one. This is how we can split or separate these two metals from these two elements from a compound, calcium and chloride. So basically electrolysis helps in decomposing the compounds. Okay, we have taken one more example, that is lead bromide. So +2 is for lead and bromide is for -1. We will do the same thing. We will take a molten salt of these lead bromide as an electrolyte and filled inside this flask. We will put two electrodes, positive and negative. So we can see positive ions will go through the negative electrode and the negative ions will go towards the positive electrode. This is how we can separate bromide and lead from the compound. So electrolysis is basically helps in decomposition of the compound. We can split up the two elements and we can extract the two elements through electrolysis by passing the current through the electrolyte. Electrolyte is basically the molten salt of that particular compound. Remember that. Okay. Now, as we have studied about the electrolyte, there is one more concept that is known as refining, electrolyte refining or refining of metals. So what we'll do, application of electrolysis for extracting the metals, purifying the metals or cleaning the metal. So what we'll do now in electrolytic refining is like that same process as it is the application of electrolysis. We will take a flask, we will put these two electrodes are there which are being connected, right, with the batteries there. So negative, positive, the positive one is anode and the negative one is cathode. Like this, the whole structure, the whole framework is same because electrolysis is happening. But now, since in electrolysis we are decomposing the compound, but in electrolytic refining we are now separating the two metals. Okay, so we are using the technique of electrolysis by passing the current through these two metals in order to find them. Okay, in order to refine them, right? Electrolytic refining is a special application of electrolysis used to purify the metals or refine the metals. It involves using electrolysis to refine impure metals and obtain a high purity form of the metal. When these electrodes are being connected to the battery, in the positive side, or you can say in the positive anode, we are going to put the impure metal. Okay. And in the negative terminal, which is cathode, we are going to attach it with the pure metal. Now when we pass the current through this electrolyte solution, so what will happen? All the impure metal will come to the negative cathode, right? And then we can extract the metal, pure metal from the cathode. Okay, like this electrolytic refining happened through the process of electrolysis. Electrolytic refining is the part of electrolysis or is the application of electrolysis where we extract the pure metal from the compound, or between the two metals we can extract the pure metal from the impure metal through electrolytic refining. And now we are going to practice some NCERT questions. Let us see the answers of these NCERT questions. Which of the following pairs will give the displacement reaction? We can see there is a sodium chloride solution in copper metal. So we already know the highly reactive metal is going to displace the low reactive metal. What will be the answer from this one? The answer is D option. Question: which of the following methods is suitable for preventing an iron frying pan from rusting? We already know applying the coating of zinc, which is also known as galvanization. Okay. Next question: an element reacts with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be, since we already know that it is a high melting point, this is going to be the metal only. This compound is also soluble in water. So what will be the compound? Calcium, carbon, silicon or iron? So answer is calcium. Now food cans are coated with tin and not with zinc because zinc is less reactive. Zinc is less reactive than tin. Okay, otherwise tin will get reactive, right? To whatever we will put, no, this any type of drinks will get react with tin. So zinc is being applied. Next question: you are given a hammer, a battery, a bulb, wires and a switch. How could you use them to distinguish between sample of metals and non-metals? We already know the metal which is going to hammered up, right? When we hammer it down, it is going to convert into thin sheets, then it is a metal. And in non-metal, it's like brittle. Yeah, they are brittle. They're going to break down, right? Bulb, wires and switch, the metals can conduct electricity as well because they are ductile, right? We can change the metals into wires, right? Assess the usefulness of these tests in distinguishing. The usefulness is that they conduct electricity. What are amphoteric oxides? Give two examples of amphoteric oxides. So all those amphoteric oxides are considered as the metallic oxides only. Amphoteric oxides are considered as the metallic oxides only, which are going to, when they are going to react with acid and bases, they are going to give out salt and water, like the neutralization reaction. All the metal oxides which goes through neutralization reaction and gives out salt and water, they are known as amphoteric oxides. Like sodium and chloride, these are the two examples. Name two metals which will displace hydrogen from dilute acids and two metals which will not. So basically sodium and magnesium, right? They can displace the hydrogen, and copper and silver. I am going to write it here. Sodium and magnesium which can displace, and which can't because they are highly reactive, right? And which can't, it can be copper and silver, less reactive. Okay. Next question: in an electrolytic refining of a metal M, what would you take as the anode and the cathode and the electrolyte? So we already know that electrolyte is like a salt molten solution. So we are going to take the salt molten solution of that metal M, and in the anode we are going to put, since it's the negative, so we will put the impure metal, and here in the cathode we are going to put pure metal. I have already told you in electrolytic refining, an electrolyte is a salt molten solution. It should not be aqueous, remember that. It should be the molten solution, okay, as an electrolyte. Pratyush took sulfur powder on spatula and heated up. He collected the gas evolved by inverting a test tube over it. It is shown dry litmus paper. It will have no change, okay. and moist litmus paper is going to turn the red. Okay, write a balance equation for the reaction taking place. So we already know that there is a sulfur powder which is going to react with oxygen because it's like burning, heating up, right? So it will give out SO2. And when the moist litmus paper means there is water, right? So it will give out hydroxide, right? It will give out H2SO3. Okay. State two ways to prevent the rusting of iron. First one is polishing, and the second one is galvanization, where you can coat the iron or the steel metal with the what? Zinc. Okay. What type of oxides form when non-metals combine with oxygen? So there are non-metals when get like what is also acidic oxides and neutral oxides basically. Okay, neutral oxides, you know, no, the water one. Okay, when they get react. Give reasons. Platinum, gold and silver are used to make jewelry because they can be found easily. They are less reactive. Okay. Sodium, potassium and lithium are stored under oil because they're highly reactive. They can vigorously react with the oxygen or carbon dioxide. Highly reactive. That is why. Aluminium is highly reactive metal, yet it is used to make utensil for cooking because you know aluminium used to form the coating, okay, which can help it to prevent reaction with the other metals, okay, or with the food as well. Carbonate and sulfide ores are usually converted into oxides during the process of extraction because I've already told you it is easier to extract the metal from their metal oxides despite extracting the metals from their sulfides or carbonates. So that is why all these metal sulfides and carbonates are first converted or reduced and form metal oxides because it is easier to extract the metals from metal oxides. You must have seen tarnished copper vessels being cleaned with lemon and turmeric. So when these acids are being used, these acids can help in dissolving that coating and making that metal cleaned. Differentiate between metal and non-metal on the basis of the chemical properties. We have already learned about this in the content. We went door to door posing a goldsmith. He promised to bring back the glitter of old and dull gold ornaments. An unsuspecting lady gave a set of gold bangles to him, which he dipped in a particular solution. So what will happen? It is talking about the aqua regia, you know. That man has dipped her gold jewelry inside the aqua regia. That is one portion of nitric acid and 3 parts of it are, what is it? Hydrochloric acid concentrated, and this is concentrated hydrochloric acid. So what will it do? It will dissolve the gold inside this aqua regia, and then that is why the jewelry feel lighter to the lady. Give reasons why copper is used to make hot water tanks and not steel, because copper is less reactive with the water. Okay, and also it will not show corrosion or rusting. It will, but it will show gradually, you know, slow. That is why we used copper for the hot water tanks. Hot water tanks are like the geysers. Yeah, geysers have the copper body instead of iron or steel body, right, or an alloy. So hot water tanks means the geysers which we usually use in the winters, right, to boil the water. Okay, together. We will meet in the next class with the new chapter. Till then, keep on learning and keep on revising. Bye bye. Take care.